So how does an AI actually decide what to do next? Well, it's not magic. It's a really methodical process called planning. In this explainer, we're going to pull back the curtain on 3 core techniques that let an AI map out its entire path from A to B, one logical step at a time. Just picture a robot zipping through a warehouse to grab a package, or maybe a character in a video game trying to solve a tough puzzle. They both need a plan to get the job done. But how is that plan actually created? That's the big question we're breaking down today. Here's our game plan. First, we'll look at the most intuitive approach, forward march. Then, we're going to flip the script with backward march. After that, we'll add a dose of reality by planning with limited resources. And finally, we'll see how these 3 totally different approaches all fit together in the AI's toolkit. All right, first up, forward march. And yeah, it's pretty much exactly what it sounds like. This method just starts at the beginning and pushes forward. It's probably the same way most of us would naturally tackle a problem. The technical term for this is progression. Basically, the AI looks at where it is right now, considers every possible move it could make, and then explores each one of those paths until, hopefully, it hits the goal. Think of it like following a recipe step by step, or just letting your GPS guide you from your current location. Okay, so let's actually picture this. An AI agent is on a grid, starting at square 0, 0. It looks at its options. It can go right to 1, 0, or it can go up to 0, 1. So what does it do? It explores both paths at the same time, branching out from each new square until it methodically finds the absolute shortest route to its goal at 2, 2. So this method is perfect for things like robotics and self-driving cars, any situation where you have a very clear starting point. Its biggest advantage is that it's just so simple. The major weakness, though, it's something called state explosion. Basically, if the AI has way too many choices at the beginning, it can waste a ton of energy exploring paths that go nowhere. But hang on. What if starting at the beginning is just the wrong way to think about it? What if you started at the end and worked backward? Well, that's the whole idea behind our second method, backward march. And it's a clever and often way more efficient approach. This technique is also known as regression. Here, the AI starts with the final goal and just asks one simple question: what had to happen right before this? And it keeps asking that question, stepping backward one action at a time until it gets all the way back to where it started. It's like seeing a picture of a perfect cake and using it to reverse engineer the entire recipe. Let's use cleaning a room as an example. The goal is simple, a clean floor. To get there, the AI figures out the very last action has to be clean the floor. But wait, what's the requirement for that? Well, the toys must be in a box. And before that, the toys had to be picked up. By tracing these needs backward, the AI builds a perfect plan starting from that initial messy room. Now, this backward approach is a total game changer for solving complex puzzles or proving theorems, any problem with a super specific, well-defined goal. Its main advantage is that it's incredibly efficient. It just ignores any action that doesn't directly lead to the goal. The catch? It's pretty useless with vague goals. You can't just tell an AI to be happy and expect it to work backward from there. So here's the key difference when you put them head to head. Forward march is like an explorer, starting from the beginning and checking out every possible path. Backward march is more like a detective, who starts with the solution and only follows the most essential clues back to the very beginning. One explores, the other deduces. But here's the thing, and it's a big one. Both of those methods assume you have unlimited resources to get the job done. And, as we all know, the real world just doesn't work that way. This brings us to our final and definitely most complex layer of AI planning. Okay, let's get real. What happens when an AI can't just do anything it wants? This is where planning gets truly powerful because it has to start dealing with real-world limits like time, money, and energy. Resource-constrained planning does pretty much exactly what it says on the tin. It makes a plan while constantly checking if it has enough resources to actually pull it off. You see, every action might have a cost, and the AI has to be sure it doesn't run out of fuel or time or whatever else it needs before the job is finished. Let's watch this play out with a delivery robot. It starts the day with a full tank of gas, so to speak, 100 units of fuel. So the AI plans its first move, traveling 2 kilometers, but this isn't free. The planner knows this specific trip costs 40 fuel units. And just like that, after the delivery, its available fuel drops to 60. Now the AI has to factor this new total into every single decision that comes next, making sure the whole route is even possible. This kind of planning is really the backbone of modern logistics, mapping out delivery routes to save on fuel. It's how those warehouse robots manage their battery life, and it's how hospitals schedule staff and resources to maximize patient care. It's all about smart optimization. So, we've walked through three pretty different ways an AI can build a plan. Let's bring them all together and think of them as different tools for different jobs. This table really is the perfect summary. You've got Forward March, your basic, straightforward navigator. You've got Backward March, your clever detective for solving puzzles. And then you have Resource-Constrained Planning, the master logistician that has to deal with the real world. Each one is a powerful tool in the AI's toolkit, and it just picks the right one for the problem it needs to solve.
AI is clearly becoming a master planner, right? It's optimizing everything from fuel to factory schedules. But as it masters all these things we can measure, it really begs the question, what's the one truly human resource, like creativity or intuition or even empathy, that it still can't plan for? At least, not yet. Something to think about.